Well, welcome back from your nice long Memorial Day weekend. Hopefully, those of you that are seniors, the 11 of you that I had, are not watching this, but the rest of you are, because you need a little bit of a refresher. And in order to do a refresher, what I'm going to do is I'm going to go over the problems from section 3, from this section 3.2, that it seemed that most of you had a little bit of difficulty with. Both the first homework section and the last homework section from last week. So here we go. The first one was question number 2 in the first homework problem, and that was 1 minus x to the 6th. And you were supposed to tell me the end. What are the end? I need to know the end. Sorry about that, got a little bit distracted. I need the end behaviors. Okay. And I was surprised that so many of you got this one wrong. Okay. So let's take a look at it. So I think what happened here, for those of you that got this one wrong, remember all you're doing is plugging in 1 for x and also -1, but this minus sign that goes there, that is part of it. So I think that's where most of you are just messing this up. Now the other thing, remember this is -1 to the 6th power. Okay, so what do you do first? Do you do do I do a negative times the 1, or do I do 1 to the 6th power? I do 1 to the 6th power, which is going to be a positive, so I'm going to end up with -1, which means as x approaches positive infinity, f of x approaches negative infinity. So then if I put in -1, again, remember your order of operations, -1 to the 6th is a positive 1, then I have a -1. So once again, as x approaches negative infinity, f of x approaches negative infinity again. So what does that mean? That means it falls left and right. And just a reminder, the negative is the one that tells you if it falls on the left, and the positive is the one that tells you if it falls on the right, or how it goes on the right. The other one that you guys seem to have some difficulty with was actually the very next problem. You had 5 minus 7 over 2x minus 3x squared. Again, what you need to do is you need to look at the whole picture here. That negative goes there. Why do I keep circling the one that has the highest exponent? Because that actually is your leading coefficient. Okay, so here, if you plug in, so you have -3 times 1 squared, well, that equals -3, which implies that as x approaches infinity, and this is the right-hand side again, that f of x will approach negative infinity. And then again, -3 times -1 squared is still going to be -3. So again, as this time as x approaches negative infinity, and again this is the left-hand side, f of x is also going to approach negative infinity. And since both of them are approaching negative infinity, that means that that falls both left and right. Okay. You didn't seem to have any problems with any of the others, but I think that, you know, the negative in front of the leading coefficient, you got to make sure that you include that. And that's what messed some of you up. When I say some of you, I mean most of you got most of these correct, but these are the two problems that seem to give you some difficulty, at least in that section. Now let's talk about the other section. There are 3 problems here that seem to give you all some difficulty, so I'm going to write the first one down. It was g of t equals 1/2 t to the 4th minus 1/2. Okay, with this problem, you were supposed to find the zeros algebraically. A lot of you started out okay, but then some of you were just adding certain things and didn't know what to do with other things, okay? So, first off, if we're finding the zeros, g of t is going to be 0. So we want 0 equals 1/2 t to the 4th minus 1/2. A lot of you did a really good job of figuring out that, oh, we do have a common factor of 1/2, so I'm going to pull that 1/2 out. So I have 1/2 times t to the 4th, but some of you didn't understand that this would be t to the 4th minus 1 then. Some of you just said it's going to be 1/2 and that's it. Now, ladies and gentlemen, what happens to this 1/2? Well, if we were to take this problem right now and divide by 1/2, what would happen? We would get 0 divided by 1/2, which is 0, and then 1/2 divided by 1/2 is 1, so we would just end up with t to the 4th minus 1. So what happens to that half? It disappears. It's just a common factor that you can divide everything by. It is not one of the zeros of the function. Several of you said that 1/2 was the zero of the function, and it's not. Okay, so now we have this t to the 4th minus 1. This is a difference of perfect squares, guys. So you still have 0 is equal to t squared minus 1 times t squared plus 1. So far, so good. Okay. Now, the next thing that we have 0 equals, notice this t squared minus 1, that is still a difference of squares, so we can factor that. This is t minus 1, t plus 1. Now, why can't we do the same thing with the other one? Because it's not a difference, this is a plus. So this is what we really end up with, and of course that 1/2 would still be out here in the front, but again, that doesn't matter. So all 3 of these get set equal to 0. Now, so I'm going to go ahead and do that. I've got t minus 1 is equal to 0. So obviously t is equal to 1. I've got t plus 1 is equal to 0. So in that case, t is equal to -1. Now these are real, true zeros, okay? If you were to graph this function would cross the axis at 1 and at -1. Now, with these problems in particular, you can't find imaginary zeros, okay? Now you could try. I mean, you could set t squared plus 1 equal to 0, but then what would you have? You would have t squared is equal to -1, and then you're trying to take the square root of a negative number, which is an imaginary number. I mean, you do know what that is. T would be what? Plus or minus I. But we don't count imaginary roots, so we don't put that in our answer. So don't count. So the only real roots that we have here are t equals 1 and t equals -1. The half clearly threw some of you off. Not being able to pull the 1/2 out and get t to the 4th minus 1 threw some of you off. Again, most of you did a really good job with this homework assignment. This is just a problem that seemed to give a lot of people difficulty. Okay. Only 2 more. The next one is f of x is equal to 3x squared minus 12x plus 3. Again, we're asked to find the zeros, so let's do it. I'm going to pull out the 3. I'm going to make this a 0. I have a common factor of 3, so I've got 3 times x squared minus 4x plus 1. Okay. Now, here's where a lot of you had some difficulty because you weren't quite sure what to do next. What you've got to realize is that you have something that you can try and factor, but you know this is not going to factor perfectly. There's nothing that you can multiply by 1 to get to 4. So you have to use your quadratic formula. All right. What's going to happen to this 3? Well, again, this is just like what happened last time. That's going to end up disappearing. So we're going to divide by 3. Divide by 3. So we're going to get 0 now equals x squared minus 4x plus 1. So then what we're going to do is we're going to take our quadratic formula and we're going to have the opposite of b, which is going to be, and just a reminder what the quadratic formula is, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's talk about this. So we have the opposite of b. Remember, guys, A, B, C, it's in alphabetical order. Some of you are having problems with the quadratic formula. I'm like, as much as you saw this in Algebra 2 and as much as we've talked about it already, it's a little bit weird. So the opposite of b would be 4 plus or minus the square root of negative 4 squared, which is 16. Please don't say that's negative 16. I'm so tired of that mistake. A negative times a negative is a positive. I don't care what your calculator tries to tell you. Minus 4 times 1 times 1. All over 2 times 1. So now I have 4 plus or minus the square root of 16 minus 4 all over 2. So I have 4 plus or minus the square root of 12 over 2. Now, this is driving me nuts, you people. Several of you keep doing this. You keep saying, oh, well, that's 2, and it's going to be 2 plus or minus the square root of 12. No, no, no. This 2 goes into both the square root of 12 and 4. Okay? So I'm going to erase that because that's a huge mistake that several of you keep making. And if you don't think you're making it, look at your answers, and you'll be like, oh, wait a minute, I am making that mistake. So I've got 4 plus or minus the square root of 12 over 2. So I still need to simplify the square root of 12. That's pretty straightforward. So it's 4 plus or minus 2 root 3 over 2. Now you can divide that 2. It goes into the 4 and it goes into this 2. So you end up with 2 plus or minus the square root of 3. That's it. That's the answer. Please stop taking the square root of 3. Don't do it. That gives you an imprecise answer. This is a precise answer, the square root of 3. The square root of 3 goes on forever. You cannot give me an actual number for that. You can give me an estimate, but then it's not precise. The square root of 3 is precise. Stop using your calculators to get me decimal answers. If it's not a perfect square root, or if it doesn't simplify like this one did, stop right there. This is it. No more. That is the answer. If you keep giving me decimal answers, I'm going to keep taking points off. Okay? Only give me a decimal answer if I ask specifically for a decimal. There's a couple of you I'm thinking of right now that continually do this. Stop doing it. Okay, last problem. Or I'm sorry, there's 2 more problems. My bad. You would think a math teacher could count, huh? G of x equals 5x squared minus 10x minus 5. Do you see a common problem here with all these problems that we have? I hope so. Once again, it's 0 equals, and I'm going to go ahead and take out the common factor. Some of you recognize the common factor but don't do anything with it, and others of you are just like, whatever. Okay. Now, once again, ladies and gentlemen, you cannot solve this without using the quadratic formula. The 5 is going to disappear. That'll be nice. So you're going to have 0 equals x squared minus 2x minus 1. Several of you just tried to tell me that you could, that it would be x minus 1, x minus 1. Really? No, because minus times a minus is a positive. That wouldn't give me a negative 1 here. And I can't have x minus 1 and x plus 1. You know better than that. So, quadratic formula is your friend again. So, again, the opposite of b, so it's going to be 2 plus or minus the square root of, again, I saw several of you tell me that this is negative 4. I mean, really? Please, negative 2 times negative 2 is positive 4. Minus 4 times 1 times negative 1. All over 2 times 1. So I have 2 plus or minus the square root of 4. Now negative 4 times 1 times negative 1. That's positive 4, so it's plus 4. Some of you tried to tell me it was 0. Like, no guys, there's a negative there. Alright, all over 2. So then I now have, so I just carried over 2 plus or minus the square root of 8 all over 2. And once again, I saw a lot of people saying, oh, well, those 2's cancel out and I just have plus or minus the square root of 8. No, no, no. Simplify your radical first. 2 plus or minus 2 root 2 all over 2. Now, the 2 cancels there and the 2 cancels there. It has to go into both of them. I have told you all that. So 2 goes into 2, that's 1, plus or minus the square root of 2. That's it. That's the answer. Once again, stop there. Square root of 2 is a precise answer. 1.41 whatever is not. So please, please, please stop trying to give me decimal answers. These are the precise zeros. 1 plus the square root of 2 and 1 minus the square root of 2. That's it. You guys make these a lot harder than they need to be. Pull out that greatest common factor. If you can factor this without using quadratic formula, great. If you have to use the quadratic formula, then use it. But make sure you're using it properly, please. Okay. Last problem. I gave you 3 zeros. 0, negative 2, and negative 3, and asked you to come up with a polynomial that has those 3 as zeros. Some of you have a really good feel for this, and others of you are just like, All right, in order to have a 0 of 0, that means that x equals 0. In order to have a 0 of negative 2, that means x would have to equal negative 2, and then x would have to equal negative 3. So, what we want to do is we want to say, well, if x equals negative 2, I'm going to start with that one. X equals negative 2. I'm going to add 2 to this side, and I'm going to add 2 to this side. So x plus 2 equals 0. This, ladies and gentlemen, is one of your zeros, x plus 2. X equals negative 3. Well, I'm going to add 3, x plus 3 is equal to 0. And then the other one, x equals 0. How hard is that? So all I do is I take these 3 factors and I multiply them. X times x plus 2 times x plus 3. Now, the thing that bothers me the most about this problem is the fact that some of you didn't even try it. I mean, come on, guys. This is all there was to it, and that's what I showed you before. Now, here, if I want the polynomial, this is acceptable, but not the best. Go ahead and multiply this out. Now, what I would do is, since multiplication is commutative, I'm going to do x plus 2 times x plus 3 first. So I'm going to leave my x alone, and then x plus 2 times x plus 3. Well, that's x squared plus 5x plus 6. Hopefully you all can figure that one out. And then I'm going to multiply everything by x, so I'm going to get p of x, because that's my polynomial, is going to be x cubed plus 5x squared plus 6x. Because remember, they asked specifically for a polynomial. Okay, this isn't necessarily a polynomial. This is just, this right here is not necessarily a polynomial. That's just the 3 zeros. And then this indicates how you get your polynomial by multiplying it together. But again, if you came up with this, I gave you credit for it. I gave you full credit for it. Some of you couldn't even start with this problem, and that was a little upsetting. But this is the final answer. This is what I'm looking for now. Okay, so once you get to this point, this x times x plus 2 times x plus 3, go ahead and multiply it out. And multiply the hard stuff first, and then multiply by the x, because that's easy. All right, guys, that's it for today. Tomorrow, we're going to have another video. This time, we're going to talk about how to put it all together. Have a great day.